Hey guys, we will do a few more problems from the concept called relative speed. The first problem is this. A stole a car from B's house and escaped in it at 3 a.m. driving at a constant speed of 60 km per hour. B realized about the theft at 5 a.m. and started chasing A immediately on his bike at a constant speed of 70 km per hour. What would be the distance covered by B when he catches up with A? The theft is at 3 a.m. and the owner of the car realizes at 5 a.m. So there are 2 points of time here. We need to find out the position of A and B at these 2 different timings, 3 a.m. and 5 a.m. See, at 3 a.m. A is in B's house and it steals the car and driving away at what speed? 60 km per hour. B hasn't found it out at that point of time. He realizes about the theft at 5 a.m. Now, B will be at this position at 5 a.m. and he realizes about the theft at 5 a.m. means that's after 2 hours. So, A keeps driving for 2 hours and he will be somewhere here. By the time B wakes up and finds out the car had been stolen, then A will be at how many kilometers from B's house? He drove 2 hours at what speed? 60 km per hour. So, this distance is 120 kilometer. That's the distance between B and A. By the time B starts chasing on his bike at 70 km per hour and A is still driving at 60 km per hour. Obviously, B will catch up with A at some point here because of B driving faster than A. And we are asked to find out what the distance covered by B by the time he catches up with A. But let's first find out the time after which B will catch up with A. From there you can find out what they want. Now look at the distance between A and B, which is 120 km when the chase starts, and the time after which B will catch up with A is given by the total distance they were apart initially by the relative speed of B and A, which is the speed of B minus speed of A. That will be 120 by 10, which is equal to 12 hours. So what does that mean? B will catch up with A after 12 hours. And how do you find out the distance covered by B when he catches up with A? See, distance, as you know, is a speed into time. We know the time after which B catches A, that is 12 hours. And what was the speed with which B kept chasing him? 70 km. So write that 70 here. That will give you the distance by the time B will catch A, and this on simplification 840 km is the distance B has covered by the time B catches A. That is the final answer to the question. The second problem is this. A and B started walking from X to Y at the same time with their speeds being in the ratio 4:1. A returns to X after reaching Y and meets B on the way back at a point which is 150 meters from Y. Find the distance of the meeting point from X. Let's draw a diagram to represent the data given here. This is XY. Both A and B are at this point, both moving in the same direction, and their speeds are in the ratio 4:1. So you can take this as 4. This is a ratio only, not exactly 4 and 1. Okay. Now, what does the problem say? The A is moving faster, so he will reach Y before B does, and he returns to X after reaching Y. That means by the time he moves from here to here, A, and comes back maybe at some point here, he will be meeting B, who walked from this point to this point. So the position will be something like this. A is in this direction. That will be the position because B hasn't reached here. B will continue to walk to this side. A is on the way back, so he will be walking to this side. And this distance is given in the problem. How much? 150 meters. We are asked to find out what distance of the meeting point, which is M, from X. That means this one. Let it be X. Now let's come to the basic result in time and distance. We know that D is equal to S into T, or D is the distance, S speed, and T time, as you know. Now this implies what? D by S is equal to T. These are all 3 variables. Let's keep a T constant. Then D by S will be a constant. Because there are problems where you will see time being a constant. This is one such problem. So This implies D is directly proportional to S, or if you take two different sets of values, they will be equal. That is the meaning of direct proportionality. This implies D1 by D2 equal to S1 by S2. So what do you observe here? When you have a problem in which time remains the same or a constant, and if there are two moving bodies, the ratio of the distances covered by these two moving bodies will be equal to ratio of the speeds. All these basic points I have covered in another video whose link is given in the description below. Now let's work out the distances covered by A and B separately. See, by the time A moves from here to here and comes back here, during the same time B has moved from here to here. This is what I meant by time being the same, because whatever distances covered by these two moving bodies before they meet at this point, the time is the same, or rather time is constant. Now let's work out the distances. A moving from here to here means x plus 150 from here to here, then here, then back another 150. This is the distance covered by A, during which B has covered just x. So ratio of their distances equal to ratio of their speeds is given to be 4:1. Cross multiply, simplify, you will get x. X plus 300 divided by x equal to 4 by 1. This implies x plus 300 equal to 4x. Yeah, you can easily solve for x and you will get it to be 100. Yeah, 100 what? Meters. And this is what we are asked to find out. See, x is what? The distance of the meeting point from x. So the final answer is 100 meters. Let's do one more problem from relative speed. A and B start walking simultaneously from 2 points P and Q towards Q and P respectively. They meet each other after a certain time t. Thereafter, A and B take 25 and 36 seconds to reach their respective destinations. If A's speed is 5 meters per second, then find Q. Let's diagrammatically show what the data say. This is PQ, A and B standing here. They're walking towards each other. Obviously, they will be meeting at some point in between. Let it be M. After crossing each other, the problem says, and A is moving on to his destination from here to here, and he reaches his destination in 25 seconds, they say. Again, B moves from M to A in how many seconds? 36 seconds. There's one more thing given, not given. They say A and B first meet at M after time T. What is T? We don't know. This is what the data say. Now there is a formula which you can use to do this problem faster. The formula is like this. Let's denote T1 as 25 seconds. Rather, A takes T1 seconds to move from here to here, which is given as 25 in the problem. And let's denote T2 for B to move from M to P. Now there are three lengths of time here. One T, the time after which A and B meet at M, and a T1, T2, the lengths of time taken by A and B to move from the point of meeting to their respective destinations. There is a relationship between T1 and T2. That relation is this. T equal to T1, T2. You can easily derive this formula, but I'm skipping it because normally in competitive exams, they don't expect us to derive anything. But how to use some standard results to solve the problem faster is what we should be more focused on. Now, using this simple formula, we can easily find T, because T1 is given to be 25, the other one is 36. This on simplification, you will get 5 into 6, which is 30. What does that indicate? A and B meet at M after 30 seconds. The question is about finding the length of PQ. PQ we can write as PM plus MQ. Speed of A is given in the problem as 5 meters per second. But what about the speed of the other one B? We don't know. So what I would like to do is both PM and MQ I will find as the distances covered by A. We won't bring B into the picture because we don't know its speed. Whereas the speed of A is given. So let's work out PM and MQ as distances covered by A. Look at PM. PM is the distance covered by A in how many seconds? 30 seconds because A and B meet at M after 30 seconds. That indicates what? A has moved with a speed of 5 meters per second for how long? 30 seconds. So you get speed into time. Speed is given to be 5. 30 seconds A travels before it reaches M. Now let's look at MQ. MQ you can take it as distance traveled by B, but instead of that, what I would suggest is take MQ as distance covered by A in 25 seconds. That's what the problem says. They say A after meeting B at M takes 25 seconds to move from here to here. That means to cover MQ, A has traveled 25 seconds, and its speed we know. This is speed. Speed into time, distance. Again speed into time, distance. Now you just simplify this. 150 plus 125, that's equal to 275 meters. This is the length of PQ. All you need to do is to memorize this result in problems of this kind. It will help you do it faster. So total I have worked out 3 problems in today's session. If there is any point you want me to clarify further in this, feel free to raise it in the comment section. I will address it there. See you guys in my next video with a few other concepts and problems from time and distance. Bye for now.